Okay, here's something a little bit different. It kind of ties closer back to the 20-1 stuff. Given the graph of y equals 1 over f of x, draw the graph of y equals f of x. So basically, we want what the graph looked like before we reciprocated it. Well, things that we know, where the asymptote is, that's our x-intercept. So we got an x-intercept there. And then at height 1 or -1, well, those are invariant points. So at those 2 points, now this is going to be a linear graph. Already I can see it goes up 1 over 1, up 1 over 1. So this graph is already done. And that's it. Now our second one's a little bit trickier because we got to watch out because of our vertex. But still, wherever the asymptotes are, well, that's going to be my x-intercepts. My invariant points are going to happen at a height of 1. So I got a -1 here, -1 here. I've got, now it looks like I've got a negative or a positive 1 right here, right at the vertex. So that's kind of lucky. Don't even have to reciprocate it. So it's all going to connect in a nice curve. And then we'll just kind of guess what the rest of that looks like then. Now we could estimate this a little better possibly. It's pretty tough because when you're looking at reciprocating, like 0.1, 0.2 makes a big difference for how it goes. So I don't know if this hits exactly at 0.2. I kind of feel like it's maybe like a third or something. So it'd be at 3, which is pretty close to where we are. So now a word problem. Marlise is producing a tourism booklet from the town of Atlin, British Columbia, and its surrounding area. She is comparing the cost of printing from 2 different companies. The first company charges a $50 setup fee and $2.50 per booklet. The second charges $80 for setup and $2.10 per booklet. Represent the average cost per booklet for each company as a function of the number of booklets printed. So we want to represent the average cost of each booklet. So let's do company 1. So it looks like our total cost, and we don't know what that is, so I'll call that C. And the number of booklets I'll say is X, so we'll say C of X. We have an initial setup fee of $50, and we get $2.50 per book. So for company 2 then, we're going to have C of X. This time we have $80 for setup plus a little bit cheaper per booklet though, so we get $2.10. And that's actually it for A. Done. B, graph the 2 functions. As soon as I see this 2.1, I'm probably going to use a calculator for that. And I've already done that for us. So I use Desmos. Your calculator will give you something else as well. And we're going to find that they intersect. Now the question is though, why do we care about that intersection point? And for you, you might care, hey, which graph is which, blue or red right now? So if I'm looking at my blue graph, blue should be cheaper. Blue gets cheaper as it goes on. So it's a little more expensive to start because our y-axis is our total cost. So the one that's more expensive to start is actually company 2. Company 2. And this red one is going to be company 1. So a little cheaper to start, but as we go on. So then the question is, well, what advice would you give her about the printing company? Well, because my intersection point is happening right here at 75 books. Each book will cost $3.17 if we round that out a little bit. If I was doing 75 books, I wouldn't care which one I did. If I was doing less than 75 books, well, yeah, I would definitely do company 1. It's cheaper. But then company 2, actually, it doesn't extend far enough, but company 2 does get cheaper the more and more books you buy, and you can see that from the slope as well.